All right, so here we're going to go to the parts of a motor. And this slide has a good photograph that I found online from Oscar Liang on labeling all the parts of a motor. First, we're talking about the physical parts of the motor, what they look like, how they're labeled. One of your assignments this semester will be to take a motor, which is actually not that hard, and to label the different parts of the motor and turn that labeling assignment in. So this will be helpful. This helps us understand which parts of the motor are which, what they do a little bit, and then we'll talk more about how they actually work together here in a second. But let's hop over to the dot cam and we'll grab a motor. Let me grab a motor here. Actually got a couple motors for you guys. Let's switch over there. Okay, so here on the screen, let me zoom in a little bit closer maybe. There we go. Okay, so on the screen we have a couple different motors. These actually go together here. Then we have this smaller one here. That doesn't really matter. They're the same essentially. We have a couple different parts of a motor. Okay, we're going to focus on the small one since it's still put together. This motor here is like a typical small brushless motor. You can spin it here with your finger. The propeller would go on top and it would spin as the motor spun, right? So here in the bottom we have some mounting holes. Let me kind of try to keep the focus of the camera here. You have some mounting holes, 1, 2, 3, 4, right? Here's the motor shaft that comes through the middle, okay? And it's got some little bushings on it. It's missing right now, which I'll talk about later in this this section about motors, but there's often a clip right here that will hold the motor together, okay? And then we have on the top side, we have the motor shaft protruding as well, where the prop can attach. This happens to be a threaded motor shaft, which but not all of them are. So you'd screw a nut on here on top of the prop to hold the prop on so it didn't fly off while you're spinning the motor and flying your plane. This part here that rotates, okay, this is an outrunner motor. That's what this type is called. Outrunner motor has this rotating part on the outside of the motor, okay, and this outside part here, okay, called the rotor. Okay, this is the rotor, and this is the stator. This is going to be bolted onto something, so it's going to be stationary. So remember, stationary for the stator, rotating for the rotor. Okay, this is also often called the motor bell, and you might have seen that in the diagram we showed a second ago. So motor bell, rotor is kind of this piece, and then we have the stator, which is this kind of section of the motor here, this thing. Specifically, this part here is the stator. Okay, not necessarily this bottom plate it screws onto, but this part with the brass, or not brass, sorry, wiring and the coils, that's the stator, and this would be the rotor. Okay, other parts you may want to know, let me try to get a little bit closer here. Brighten it up a little bit, there we go. Now, other parts you may want to know, we have some bearings inside the motor. You can see the motor shaft here sticking out. Sorry, the magnets are sticking to my screwdriver here. Shaft here sticking out, so this motor shaft goes down through those bearings and that allows it to spin without creating too much heat, right? We have a stator. These copper wires are called windings or coils, frequently referred to that way. They're wires that are around and around, basically a flower looking piece of ferrous material. So if you imagine something that, let me grab my pen here. Each one of these coils is wrapped around something that looks kind of like a T. So a bunch of these T's. A little bit, and so the wires get wrapped around those. Okay, the T is the metal. The wire gets wrapped around it and causes these kind of bundles around all those little T's. Okay, so there are coils or windings, the bearing, this is the stator. Okay, and then we have the mount holes on the bottom. On the top we have, or the rotor and the bell, we have the motor shaft, of course, right here on the top. Let's wait for it to focus. Here we go. Motor shaft protruding through here. Okay, oops. And on the inside, we have all these silver things, right? You may have noticed before my silver likes to stick to them, right? Because they're magnets, okay? So these are permanent magnets. They're magnets just like you may be with when you were a kid or in science experiments, things that are magnetic. They're always magnetic, which is important for our later discussion on how motors work. But each of these is a permanent magnet around the edge here of the bell, or around the edge of the rotor, however you want to describe that, okay? All right, so when we put the motor together, we can kind of see this. The shaft will fit into the middle there, and then as soon as we kind of slide it, it wants to jump together because of those magnets, right? And we can spin it again. And normally motors aren't that easy to take apart. I guess there's a clip on the bottom here that you have to remove in order to take the motor apart. I'll show you a motor like that here in a minute. So one size of motor. Here's a much smaller motor. Okay, wait for the focus to happen again. Camera. There we go. Much smaller motor, but you'll see it's much the same. Okay, so if we pull this off, we have a teeny tiny little stator here. Oh, sorry, the focus is not working. Let's come on, camera. There, little teeny tiny stator here. Some very small bearings. Okay, on the bottom we have the mounting holes for the motor. Oops, flicked it off screen. Sorry. Here's the mounting holes for the motor. Here's the top half of the motor. Little motor there, and some small magnets on the inside of the rotor or bell. Okay, so pretty much brushless motor you look at will be similar. Let me get a little bit back here for this big guy we got here. Okay, again, this one's already been taken, but these two halves will go together. We have some bearings in the bottom that actually got jammed in there a couple semesters ago. Oh well, this motor doesn't work anyway, but we have a large stator. Okay, the coils or windings around there. Right here we have the motor shaft. Camera, there we go. And then we have the magnets. These ones are much stronger since it's a bigger magnets and a bigger motor. And this is the rotor or motor bell. Okay, there's a small shaft protruding here. Different type of shaft you might have noticed here and here and here. Different motors attach props in different ways. This one would often have screws that come down through the prop in top of the bell, as opposed to just having the prop come on and then putting a nut on top to hold the prop on there. Just to do that. All right, so that's those are the parts of a motor essentially. Let's flip back over to the slides for a second and make sure all of them. Okay, so here on the slide again we have the windings, the bearing, the stator height and width. We talked about the stator, so that's naturally the measurements for it. This is the stator. We have permanent magnets, shaft, and motor bell. Okay, so the way these motors work. Let's go advance the slide here. Magnetic poles. Okay, so we're talking all about magnets. And I'm going to look at this slide, then we're going to break this video in chunks. But here we can see that on a motor, we have the permanent magnets on the outside, which we kind of showed on the dot cam there. And basically the number of magnets for the motor can affect the motor's, well, lots of different qualities of the motor, basically. And you can have motors that are very similar in size and shape, or almost exactly the same size and shape, with different numbers of magnets or poles. Okay, so remember magnets have like a north and a south pole, so different numbers of poles can be present in a motor. In this diagram on the right, we see an 8-pole rotor, 6-pole stator, 10-pole rotor, 6-pole stator. Okay, so you can see this one has the same amount of basically T-post things on the stator, but it has more magnets around the edge where it's at compared to this one on the left, which has the same stator, but a different number of magnets on the rotor. Okay. Typically, the number of magnets, the number of permanent magnets, I should say, will be the number of poles in a motor that's people refer. Now, you can refer to both of them, right? But if you have just one number, often people are just referring to the number of magnets. Okay. All right, let's pause it there.